Alright, welcome you guys. Today we'll be talking about box and whisker plots. And box and whisker plots are actually really cool because you can organize the information that you're given and also take a look at how the data is arranged. So let's say that your sample data looked like this. This was a test score from a class recently, and this was what the students received on the actual their grades for it. And as you can see, you can kind of see some stuff just by looking at the numbers. You can see the highest, you can see the lowest, but it's hard to see everything else. So first thing of doing whenever working with box and whisker plots and looking at it is we have to arrange the data from least to greatest. Okay, and then going from there should be a lot easier in working and actually finding a box and whisker plot. Okay, alright, so now that we've got everything arranged, we can actually start looking at it and going, okay, let's start seeing what information we have to deal with. So let's get rid of that real fast. Okay, so obviously the high is still 95, 65, but now I can actually start looking for the median. So what I'm going to do is I'm going to count my way to the middle. 2, 3, 4, 5, 6, 7, 8. Okay, so the middle is actually these two middle numbers. And if you remember finding the median that way, you just find the average between the two. So you would go 81 plus 83 and then divide that by. And we would have parentheses around this. Let's go parentheses, parentheses. We would divide that by 2 and that would be 82. Okay. Alright, so the actual median is actually 82. So that's helpful. Alright, now, if we wanted to find some other stuff about this, we need to start looking at some actual information. Okay, now, since this is the median, alright, so taking a look at this, we found the median. Okay, the median is actually also known as the second quartile, or quartile 2 is what they call it. Okay. Alright, this one would be the 0 quartile, although no one ever calls it that. It just, just know that it could be called that. And this one would be called the 4th quartile. Okay. Alright, and these are the quartiles and how they're split up. Now, if you're noticing, I skipped the odd ones because those ones are going to be in between the 0 and the 2nd and the 4th and the 2nd as well. Okay. Alright, so we've talked about we've talked about box and whisker plots. We're going to now find our quartiles just to work with it. So you have these first 3 quartiles to work with, and technically this doesn't count as one, but it's the 0th quartile. Okay. Alright, so what we're going to do is find the, we're going to use the 82 as the dividing line, so that's going to be right here. Okay, so 82 is right there. Let me move it over a little bit. It's not exactly close to 83, but you know. Okay, and what I'm going to do is I'm going to find the median between 82 and 65. Okay, so 1, 2, okay, and that's going to be the 77. So the 77 is actually my first quartile. Okay. And then I'm going to do the same exact thing between 83 and 95. 1, 2, and there we go, 89. Okay. This is going to be quartile, quartile 3, the 3rd quartile. Okay, now the inner quartile range, and it's actually called IQR, is actually going to be the 3rd quartile minus the 1st quartile. Okay. Alright, and in this case it's going to be 89 minus 77, which is going to be 12. Okay, so there's about a data spread of about 12 in between. Now here's some interesting things. If I actually have another set of data where the median was the same, it was 82, but then I found out the inner quartile range was about to be 6. That means this is, the info is clumped more closely together. Okay. Alright, and that data set. This one is info is spread out. Okay. Alright, so the interquartile range can actually help you identify if something is really kind of close to each other or if they're kind of spread out and stuff, and just work that way, okay? Alright, now drawing it is actually really kind of easy once you have these numbers because it's just a piece of cake. Okay, so normally you want to have your highest and your lowest already marked out, so that's really easy. Alright. Now, if you notice there's a distance about 30 between this, and that we would call that the range. Okay, so I'd have about 15 here, so this would be about 80. Right, and this should be about, I'd put an 87 here, and about a 72 right here. You can use decimals if you want. I'm not going to in this case. Okay, so I have my whiskers pretty much all set up. Now, what I'm going to do first is I'm going to actually draw. I would actually draw my median. Now, my median is 82, so I'm going to go over here and draw it like this. So that's my median. If you want to draw it, you can. Or, I mean, if you want to mark up right above it, median, that would probably be the most preferable. Okay, now if you notice I already did the lowest and the highest, so I'm all set with that. Now I'm going to use the third quartile and the first quartile and get that all marked out. So 77 should be about right here, and you want to have it pretty even with the median so that you have a nice looking box when you actually draw it out. Okay, then 89 probably be a little bit right here. Okay, and you can mark it above so that people can read it, or you can read it later on when you come back to this and you're going, what did I just write? Okay, alright, now that you have that information, you can actually just complete the box along the top and the box along the bottom. Okay, now if you notice earlier when I was talking about the interquartile range, I could talk about the spread. Now we could really see it. Okay, now here's the really cool thing is that the information between the 65 and this 77, this is 25% of the information. So the information between the 0th quartile and the first quartile, that's about 25% of the information is in there, which makes sense because that actually works out that way. Right. Then between the first quartile and the median is another 25% of our data, and then same thing here, so 25%, 25%, 25%. Now as you can see, you're probably going, wait, those 25% aren't really evenly distributed. These two in the middle, or this between the first and the second, and the third and the fourth, those are really compact, whereas these ones right here are really spread out. That's another reason why a box and whisker plot works out so well, is that you can actually find this information really fast, really easy, just by looking at it. Okay. Alright, so interquartile range. Alright, next thing, percentiles. Okay, now if you find that you're getting a score above 82, you're in the 50th percentile, just working with it. Why? Because if I divide all of the numbers below 82% or 82 by the total amount of numbers, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, and there is 5 numbers less than that. Okay, I happen to circle the wrong solution. Here, let me move this down. There we go. Okay, there's 5 numbers less than that, then that would be 5 out of 10. So that makes sense. So that'd be 50% in there. Now, what about what percentile am I getting if I score, 91? Okay, so if I score 91, I would seriously go 9 divided by 10, and that would be the 90th percentile, is what I would be scoring at. And the percentiles help compare you to the rest of the subject in this. For example, when you're taking a CRT or you're taking an SBAC or an end-of-course exam and they give you the percentiles, you can actually tell how you rank with the rest of the population that actually took that test. All right. Now, what you could also do is the converse of this too is finding percentiles. Is if you scored above 91, but you didn't get above a 95, then you could also say I scored less than the top percent, and that would be 1 out of 10, which would be 10%. So I scored less than the top 10%. I was in the top 10% of the actual scoring. Okay. A lot of cool stuff you can do with box and whisker plots. I love it and how it works. Okay. All right. That's it for box and whisker plots. I'll talk to you later. Bye.